Let a and b be integers, prove that a cubed divides b cubed if and only if a divides b. First direction is so easy, right? A divides b, that means b equals ka. You can look at this at home on the GitHub page if you want. The other direction is harder. A cubed divides b cubed implies a divides b. Now, a cubed divides b cubed. Why is it that I can't just say b cubed equals k cubed times a cubed? Pardon me? Why can't I just say that b cubed equals k cubed a cubed? Tejas? Yeah, so I'm guaranteed that b cubed equals k times a cubed. I'm guaranteed that b cubed equals k times a cubed, where k is an integer, but I'm not guaranteed that that integer is a perfect cube. So it could just be 7. 7 is an integer. I'm guaranteed that it could be any integer. It could be 7. 7's not a perfect cube. So I can't just start with that in my proof. All right, so you guys proved it? Who proved it? You thought about it? Yeah, yeah. How did you prove it?
I showed you, didn't I?
I don't, but that was just on our way out and it was too fast, right? So that proof, I didn't tell you that that proof is definitely okay, did I?
No, I went and did more to it actually.
Okay, so what's the first step in this proof?
So we say that A and B can both be written as the product of prime factors.
All right, okay, so stop there. You're going to give too much to the other students then. So we write A and B as a product of prime factors. Give me a number, a composite number between 1 and 50.
16.
16, okay, 16 equals 2 to the 4. All right, another number between 1 and 50 that's composite.
42.
42, okay, so 42, you can still see this? That equals what, 6 times 7, right? So it's 2 times 2 to the 1 times 3 to the 1 times 7 to the 1. Is that right?
Yeah.
Okay, so any number, composite number, you can factor it into powers of primes, all right? Now, let's make these the same. This is actually 3 times 7 with what exponents? 0. Okay, so whatever number of primes the bigger number has in it, or whatever, the one that has more primes, you make that, maybe B has more primes in it. So I put P1, P2, all the way up to PR. And it has some exponents. And A and B are integers, right? So A has P1 up to PR. And exponents for each of these primes, right? And they both go up to R, because if one of them has fewer primes, we can just put a bunch of zeros in the exponents. Okay, you got it? Now, what happens if A squared divides B squared? Then, so let's use, do they have different colored chalk here? They don't have different colored chalk.
No, you gotta bring your own.
Ah, that sucks. All right, so let's square this. So it's this squared, then I just do this, right? If I'm squaring this, then I'm just squaring each of these, right? And if I'm squaring this, then I'm just squaring each of these. You can do the same proof with cubes instead of squares, but let's just do squares for now. Okay, now if this divides that, then that means this has to divide that, and this has to divide that, and this has to divide that, right? So the powers here have to be at least as big as the powers there, because what happens if I have a number here, like 9 to the 7, and here I only have 9 to the 6? How can that divide this? It's too big, right? That's too big to divide this. So all of these exponents have to be smaller than or equal to the exponents here. You got it? Yeah, look it over at home, okay, when you get the chance. So we have alpha I is less than or equal to beta I for all I, all right? And that means that A divides B, all right? Now, if you're doing this type of problem at home, Tejas? Not cubing? Why is it squaring rather than cubing? All right, so this proof works even if you wanted to prove that a to the n. If you wanted to prove that a to the n divides b to the n implies that a divides b, the same proof works. So instead of squares, you put cubes. So you can have 3, 3, or you can have n and n. But the main point is that these exponents have to be less than or equal to the exponents. So if I have a to the n and b to the n, then I'm going to have the same number throughout. So instead of 2, I have n. I'm going to get chalk all over my clothes. Okay, but we have n, 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 n. So n's are all over the place. Those n's don't matter. What matters is that the 4 has to be less than or equal to the 1 if you want 16 to divide 42. So whatever this exponent, this is alpha 1, this is beta 1. The alpha 1 has to be less than or equal to the beta 1. All the n's are the same, so those we can ignore, and it's the alphas and the betas that matter. All these alphas have to be smaller than or equal to the beta. If it's larger, if I have 7 to the power 7 and only 7 to the power 6, there's no way that that divides this.